So this review is on a Campagnolo Super Record 11-speed crank arm. So this guy here, this is the non-drive side, and yeah, as you can see, it's cut in half. There you go. Now this one came in because it was damaged in an accident. I can't remember whether it was hit by a car or something like that, but in this area here, it's cracked and all through, and I'll show you some pictures of that later. But basically, it was in the bottom bracket and it got impacted like that, and basically bent it. So, and as you know, carbon doesn't bend; it either takes a load or it breaks. So in this case, it broke. So let's have a look at it. In this picture, like I've just got another, it's a Campag Record, not Super Record. This one's actually a Super Record. The difference is the titanium axle, and the Record has got steel. So I think Hambini was talking about these cranks a little while ago, and there was a lot of comments and stuff on, how the bolt on the Super Record is a titanium bolt and it's a left-hand thread, all these sorts of things. So I won't go too much into that sort of stuff. That's already been covered. I'll talk more about the carbon and the way it's made and put together. There's a sort of a close-up of the crack on the outside. Yeah, so that's just here. Now when we cut into it, which will be the next slide, you can see a delamination, and you can see right through here. It's quite a big delamination that's sort of propagated through the whole structure. So so it obviously took quite a bit of force, because that's a fairly thick section. I mean, there is a transition in thickness there, so that's a bit of a stress concentration, but it would have been quite a large force to be able to do that. So in this image, you can see the marble effect that people talk about. It's and so this is made out of like a sheet molding compound, where it's a whole bunch of shorter fibers, which are all stacked, sort of almost like a quilt, if you like. So the fibers are just sort of basically all randomly orientated in a sheet, and then those sheets are put down, and then it's compression molded, and that's what gives it the sort of appearance of the marbling. So it's different to the marbling that you may see on a BMC frame or other frames which have just clear coated, where they've sanded through plies in the factory, and I'd imagine that's unintentional. In this case, it's intentional. It's meant to be like that. Sheet molding compound, SMC, if you want to look it up. So this is inside. That's what it looks like on the inside. So you can see that there's a thread molded in. We'll insert it in this end, and it's hollow all through this section here. So that's all hollow, and so the way it's done is they put a material like a soluble mandrel. I'll remove that. Oh, it's a highlight. I need to erase it. There we go. There we go. It's erased. They put a soluble mandrel in there. Now it can be like a low melting point metal, and it's something that needs to be have a high enough compressive strength that it can take the compressive load and the temperature of curing. So basically, they have this mandrel, they wrap the fiber, this sheet molding compound around it, they place it in the mold, which then is it's a two-piece mold. It's pressed together, and yeah, and that's what you end up with, this hollow cavity. Now I'll show you. Then there's a little plug where they then remove that mandrel, because once that's all encapsulated, so that's sort of all sealed in there. So then you need to get it out, unless you want to leave it in there. But because it's a low melting point metal, it's probably quite heavy. A lot of those are sort of lead based, or OHS probably not lead so much anymore, but some of these antimony maybe, or one of those. Anyway, you need to get that out. So let's have a closer look at the thread. So you can see that that's sort of been threaded in. So it's a thread with a thread on the outside. Now, I have had quite a number of these over the years come in where that thread has disbonded. So it's basically come loose in there. Sort of it's unscrewed. Particularly if your pedal gets jammed in. If you haven't put anti-seize on your pedal, and you then go to undo the pedal, and you can't undo it because it's really tight, so you get a really big spanner on it, and then you pull that insert out basically. Usually it can be bonded back in without any issue, but the other thing here is you can see the profile of that insert, how it sort of tapers away. So the wall thickness through here is thicker than what it is to the middle of the arm, and also the step in this region here. Also big, solid, chunky laminate at the end. Now I don't know. I haven't, like this is a 172.5 mil arm. I'd need to have a look at some of the other arms to see whether they just put that insert in various places along that sort of thicker end, or whether they actually have a specific mold. I'd need to check that. I'm not sure off the top of my head. Okay, let's go to the next slide. Okay, so here is that little plug I was talking about. So there's a hole here, and that just happens to be under where they put the sticker with the serial number and the crank length, etc. So that sort of covers that up in that little space there. So that's sort of effectively a drain hole for this low melting point metal, which is then removed after cure. So I don't know specifically what the cure cycle would be. Typically with these pre-pregs, it might be 120 degrees or 140 degrees or something like that. But in this case, it would need to be lower than what the melting point is, and then you do like a post cure. So when you post cure the part, you take it to a higher temperature to drive up the glass transition temperature, the TG. Now you do that in one step, so you'd be draining that mandrel at the same time as the post cure. So the process is doing two things. It's adding environmental stability by pushing the cure, and removing that mandrel. So if we look here, we can see how smooth the internal finish is through here, and you can also see the ply buildups. Like if you look closely through here, I'll erase that so you can see it, but have a close look through there, and you can see actually orientations of the fibre. When I cut this up, I didn't polish it I didn't polish it at all. So that's just straight off the saw. So if you polish that surface, you'll be able to really have a good look at what the fibre orientations are and all that stuff. But yeah, you can see how this mandrel has created a very nice uniform internal surface, and so there's no wrinkles or thickness variations and all that sort of stuff. So, this compression molding type process, and some people call it forged carbon. It's just sort of a bit of a trendy name, but it's it's basically being pressed with this sheet molding compound. What else? Yeah, you can see the damage through here a little bit as well. But yeah, so I'll erase that. Here we go. So yeah, the inner thickness, the inner surface is thicker through here than it is on the outer face. So yeah, they would have done some engineering calculations on the loads, etc., and optimize supplies accordingly. We hope so, at least. Okay. The axle then is pressed in and bonded. You can be looking at it there as well. Like you can put in front of the camera might help. So obviously, being a titanium axle, that's nice from a galvanic corrosion point of view. They're both like titanium being quite a noble material. You don't get the galvanic problems like you would if you had an aluminium or magnesium or something like that. But not that you want to make an axle out of that small diameter out of magnesium or aluminium. But so you can see that like the bond through there as well. There we go. Go to the middle. The camera's back to front. So I'm doing a great job here, aren't I? There we go. Let's see if I can look down the middle of it. No, close. No, there we go. So it's bonded in, and I won't, as I said before, I won't talk about the all the bearings and the tolerances and all that sort of stuff. It is a hearth joint. It's probably quite expensive to machine that part. I do see problems like particularly with the tie because the tie will flex a little bit more, and if the cups on the frame that the bearing sits in are not supported well enough, you can get movement at those cups, and those cups will tend to creep around a little bit and can be create some wear and some noise and a few things like that. So as I said, I won't go too much into that. Okay, so here's the main update on this presentation. So there was some talk about I should have cut the axle through, so we can see how it's joined. And that's a good idea. I had a little bit of time to do that, although the titanium was quite it's not a nice material to cut with it's just did with a hacksaw. So here you can see how the axle is attached to the crank arm. So it's not just pressed in like I said in the previous slide. It's actually got some mechanical engagement there, sort of almost like a thread, and then it's bonded as well. And so you can see the adhesive, like there's like an adhesive injection or something like that there and there. So that would go around the whole circumference of the axle. Now the axle's been machined. It's really beautiful machining. So through here you've got nice contour. Obviously where the load is greatest through here, where the bearing sits, you've got increased wall thickness, and then a nice smooth transition to the thin wall. So nice thin wall along here, and then where the hearth joint is and the thread, it ramps up in thickness again. So really nice piece of machining there. And having these this mechanical interlock with the arm as well as the adhesive, that's not going to go anywhere. And you can see also where the failure was through here. It's sort of, so that whole section of the of carbon is cracked, but there's no indication whatsoever of a disbond at these mechanical bonded interface there. So so that's a great solid design. So yeah. So the other thing I've done on this, I've just, you probably noticed, maybe you didn't. I've increased the size of the pictures on some of the images a little bit as well. So this is the update. Yeah, I got the blue T-shirt on this time, and I've had a haircut. So yeah, the difference a week makes. It's still Friday afternoon. So we'll go back to the last. Well, yeah, then we'll go to the last slide, which was the original presentation, and yeah, hope you enjoyed this update. Okay, thanks. Bye. So the last thing I'll talk about is, there's two things on this slide. So you can see on the threaded insert here, it's got that sort of olive greeny sort of color. Now that's a surface treatment, like a preparation for bonding. So that's good. They've taken the precautions, to avoid corrosion and promote the adhesion and all that sort of stuff. As I said before, I have seen those inserts come loose, but it is more when there's a handling sort of thing as much as anything else, I'd say. And then the other sort of thing, which is a bit of a negative, and you can just sort of see it a little bit through here, through there, is the graphics. They tend to go yellow over sort of quite quickly. So the clear coat that they're using obviously gets affected by the UV and goes yellow. And so, what used to be a white, quite a striking white graphic, ends up becoming like sort of a dirty yellow sort of white. And this is not a cheap item by any means, and it sort of detracts from it. I've seen it on some of the frames as well, like the Pinarellos and the Colnagos and Cipollini's to a certain extent as well. That you put them out in the sun and they go yellow. The older Specialized used to do it really badly as well, but they seem to be a bit better now. But the best thing, if you're paying this sort of money, I don't think your clear coat should go yellow on your however many hundreds of dollars crank arm. So bit of a down, points against from that. But overall, they are a nice, well-made crank arm. I don't use them myself. I'm running Shimano stuff, I'm on current road bikes. I'm running SRM cranks, the old SRM Pros. But they are a nice, well-made crank. The crank itself doesn't have too many problems. I spoke about the bearings in the frame. That's sort of the primary thing I've seen, and then the pedal insert if you do something stupid with it. But apart from that, not too bad. So we'll leave it at that, and I've got an FSA crank here as well, which I can do and show you the difference between this one and the FSA, and there's quite a big difference, let me tell you. So that's it. I thought I'll do this one because this is much quicker than doing. I've still got the Cinarello comparison to do. That's going to take a lot of time. Things have been really, really busy. and I'll get to it when I can. And yeah, we'll see you again soon. Okay, bye.